All right, this is hopefully going to be a quick video, just kind of finishing up those notes that we've been doing on parent functions. So it says first identify the function family. I've already done that. It's an absolute value function since it has the bars. And then you're supposed to describe the domain and range, and you can use a graphing calculator just to verify. So if you have a graphing calculator, you want to pull it out. And you're going to hit this button right here, the y equals, and it'll take you right to this menu. So the function we're graphing is 1 divided by 3, 1/3. And then for absolute value, you're going to go to math. And then you're going to scroll to the right, num, and it's already selected. And then we just hit enter. And then in our bars, we want -x. And then outside of the bars, we want +4. And then we just hit graph. And there you can see it's kind of a wider V, and it goes through the point 0, 4. So that's what I'm going to draw on my paper here. When I'm doing a graph, I just want to specify it goes up 1, 2, 3, 4. So there it is. And then it's just kind of a wide V. Just a rough sketch. All right, so domain-wise, it looks like it goes forever, left and right. So for domain, we're going to want to write -infinity to +infinity. And then for range, however, the lowest point is at 4, and it is equal to 4, and it goes up forever, so +infinity. The last example shows us a table, and it says, what type of function could you use to model the data? So really quick, we're just going to look at what's going on with these numbers. So these ones are going up by 1 each time, and these ones are going up by 12 each time. So when that happens, we call that a constant rate of change, and when that happens, you want to use a linear model. So if you were to graph these points, they would make a perfect line. So that's all I'd put for explain. I'd say the rate of change is constant, so it'll be a linear function. And letter B says if the bike's teammate rides at the same pace but leaves an hour later, so basically we're an hour less for each of them, what type of transformation does this represent? So if you're not sure, you can always go about making your own table for the new rider. So basically we're just trying to think, okay, so if the first rider rode 12 miles in 1 hour and the second rider is an hour behind, then at 1 hour the second rider has ridden no miles yet. And then after 2 hours, the second rider would have covered 12 miles. So remember, he's an hour behind whatever this guy is. So whatever this guy did, you just take off 12. So at 3, he's actually at 24, etc. So if you were to graph that, 1, 0 is about here, and then 2, 12 somewhere here, and then 3, 24 somewhere like this. It's still going to make a line. So this is our second rider's graph. And our first rider would actually be 1, 12, 2, 24, and etc. So his line looks like that. So they're asking, what type of transformation does this represent? And it would be a horizontal shift to the right. And since it's an hour, we'd say 1 unit. So again, that's just from making a table using your logic and then just comparing the graphs. So you should be able to see that relationship.